All right, we're live, and we're here with Carl and myself.
Carl, aka Georgie.
Yes, Georgie and myself. And so this week, start talking about acquiring behavior through inheritance. And if you've done any work in object-oriented programming, you're probably familiar with inheritance.
Yep.
So I don't see this chapter. I think we'll be able to get through this chapter pretty quickly. So chapter 6. Again, I'm not going to read it word by word. That's what the book is for. You do it on your own. This refactoring mob gives us a chance, to discuss the topics. I'll go through and read what I think is important, and then if there's any questions or you want to discuss more about it, just let me know. And in places where there's code, we'll just code it up and do that if we feel like. I don't know if all code needs to be coded up, but we can definitely do it. The option is there. All right, so am I sharing my screen?
Okay.
No. Okay. Share screen. There we go. Okay, so I'll just read the first intro paragraph. So well-designed applications are constructed of reusable code, small, trustworthy, self-contained objects with minimal context, clear interfaces, and injected dependencies are inherently reusable. So this book has, up to now, concentrated on creating objects with exactly these qualities. So inheritance is a sharing technique, and this being an object, Ruby being an object-oriented language, it's built into the very syntax of the language. So this chapter offers a detailed example of how to write code that properly uses inheritance. So the goal of the chapter is to teach you to build a technically sound inheritance hierarchy. Its purpose is to prepare you to decide if you should use inheritance or some other method. And then, so this chapter contains a tutorial that illustrates how to write inheritable code. And then chapter 7 expands those techniques to the problem of sharing code via Ruby modules. So understanding classical inheritance. So inheritance is, at its core, a mechanism for automatic message delegation. And we can see that in Ruby quite simple. If we create a new object, actually, let me bring this up a bit, maybe make it larger. And so a very simple use case of inheritance is that when we create a class, any class, it automatically inherits from the object class. And so when we go to instantiate this new class, any class, it inherits all of the methods of its superclasses automatically. Well, so if it doesn't, this class is empty, we didn't define anything in it, but if we check out its methods that it will respond to, we get back all these methods. And so we can send it, even though we didn't define this method here is any class nil, it says false. It's not nil. It's a class. It's an object. And that's because this is defined in the object class. So it didn't find it in any class, so it starts looking up the inheritance chain, and it found it in the object class. So inheritance, it inherits methods from its parent classes. And so you'll hear the word classical inheritance used throughout this book, and it's a term. The term classical, it's just a play on the word class. It's not a node to an archaic technique. So, for instance, JavaScript has prototypes. So it uses a prototypical inheritance, and Ruby also has modules. We'll get into that more in the next chapter. So, so this chapter, it's going to go through an example that misuses that to show what the uses and misuses of inheritance are, so we can understand them better. It's going to go through an example. And it begins with a single class and goes through a number of refactorings to reach a satisfactory set of subclasses. And so first starts off recognizing where to use inheritance. So again, assume that Fast Feet are our company that we're doing business with. Leads road bike trips. Road bicycles are lightweight, got curved handlebars, skinny tires that are meant for paved roads. Then mechanics are responsible for keeping bicycles running. They need spare parts to take with them on each trip. So we'll get them their bicycle class that they're asking for, so that they can decide what spare parts to take. So their application, okay, so it says Fast Feet's application already has a bicycle class shown below. So here is the bicycle class. So when we initialize it, it initializes the size and tape color. Then we can ask it for its spares. So the mechanic knows what spares to take. It says, okay, you need a chain that's for 10 speed, you need a 23 millimeter tire size, and you need tape that's of a certain whatever tape color, red, blue, green, whatever we passed into the initialize method. And then when we create the bicycle, we can assign it a size, and we can assign it the tape color. Then so when we ask for its spares, we get tire size 23, chain 10 speed, tape color red, so the mechanics can be prepared for the bicycle trip. And that's all good and everything. As she mentions that this class works just fine until something changes. Imagine that Fast Feet begins to lead mountain bike trips. And so that's when we get into adding new behavior and then refactoring. So do we want to type this up and go through it, the refactoring ourselves? Or should I continue just skimming the book? Oh, hey, Georgie. Seems like you got dropped from the chat.
What? You can't hear me?
I couldn't hear you earlier. Seems that it was dropped from the chat. Now I can hear you.
All right. So I was saying I don't know about going along with the code or not. What do you guys usually do?
Okay. Yeah, I mean, we usually type it up and go through it. Hey, Gideon, how's it going?
Yeah, hi.
This is your first time joining, or?
Yeah, it's my first time.
Cool, welcome. Yeah. All right, so yeah, let's just.
Sorry.
Oh, go ahead.
I was just gonna say there's usually more of us to Gideon.
Yeah, we're missing a couple people today. It's all right. Um, if you don't know, you can make your screen bigger on the StreamYard by right-clicking and then selecting, I think it's view controls, show controls.
It's just full screen, interactive.
Um,
So if we should code along, last time you shared a link for Visual Studio.
yep. Yeah, let me get that started. Start collaboration session. All right, so it'll be in the private chat here. Go ahead and click on that link.
Gideon,
Yes.
yeah, how do you expand the screen? As in, my screen is somehow small.
You right
It's not
click
possible.
on the video part and then click on full screen.
Okay. Thanks.
Show me what I should do. What do we have already? Okay. Let's just do this. Yeah, let's do this. Directory. 6. Okay. So, let me try to, yeah, usually go like this. I'll get that up over here.
So first, just want to type out the class from the book, right?
Yeah, we'll type up this bicycle class here that's got an initialize method and a spares method.
So someone types out. I don't know. Should I get started?
Yeah, go for it. Yeah. And then, yeah, if you want to join in the VS Code session, Gideon, you can help us do some typing.
Yeah, sure. It's still loading on my end.
Okay. I'll be right back in 1 minute. Let me get some water.
So Gideon, maybe if you see me make a spelling mistake or something, you can say something.
Okay, sure. Yeah, you made a mistake. Line 12, yeah.
Thanks, I also just saw it. Nick, you also back?
Yeah, I'm back. Yeah.
You could have also just copy and pasted, but I wasn't sure. I thought for me it's just good practice in typing.
Yeah, yeah. I think I've tried copying and pasting it before. I'm not sure if it works that well. I don't know if you need the practice in typing. But yeah, I don't know. There's benefits and probably some disadvantages to typing it.
Well, it's just a time thing now, but I wasn't sure, like, how do you guys
Yeah,
normally do it?
yeah. We usually type it out. It can definitely be time consuming, which is not a benefit. Um, one of the benefits is that I don't know. Sometimes we make mistakes and we have to troubleshoot it. So it kind of that can be kind of a benefit at times. And then sometimes we find mistakes in the book. Not in this book. This book's pretty well done. In
Yeah,
the
it's nothing.
in the refactoring book, there were some mistakes. But yeah,
Okay, I see on the next page it continues. I thought I was done.
yeah. So we do bike.size and then bike.spares. You don't need to type the comments out. It's fine. Cool.
All right. Cool.
That should be it. So if we save this and run it, then we should what is this? Ruby bicycle.rb. Oh yeah, I gotta go. Now we got syntax error, line 22. Oh, we need a comma. All right,
Include the print statement.
so let's try this again. All right, everything works. Yeah, we should probably do puts. I think. There we go. All right, so we get M and we get the spares. So cool. So let's move on. Okay, so we got our bicycle class. It does all that great stuff. So the bicycle instances respond to spares and size and tape color messages, and a mechanic can figure out what spares to take by asking each bicycle for its spares. And then, despite the fact that spares method commits the sin of embedding default strings directly inside itself, the above code is fairly reasonable. So this model of bicycle is obviously missing a few bolts, and it's not something you could actually ride, but it's just an example, and it will do. So this class works just fine until something changes. Imagine that fast speed begins to lead mountain bike trips. So there's a clear difference between mountain bikes and road bikes. This is a picture of a mountain bike. It's got a sturdy frame, it's got fatter tires, it's got straight handlebars, it can have suspension, front suspension, it could have rear suspension, or both. So then your design task is to add support for mountain bikes to FastFeet's application. And the only difference between road and mountain bikes are that road bikes need handlebar tape and mountain bikes have suspension. So right now we have this concrete class in here, bicycle, and it's pretty specific. It's got some road bike specific stuff in there. But it's what we're first going to do is we're just going to shove mountain bike right into this class and get it going. Solve our design-ish, the use case they want implemented. So we add front shock, rear shock, and can initialize all that stuff. And then when the mechanic asks for spares, if it's a type road bike, it responds correctly. Else, it responds with mountain bike type. So, and then after we get this all typed in, then we start seeing how this can be approved. What's the downfalls of doing it this way at first, and then refactoring and stuff like that. So, so we got style, size, tape color, and then we got, let's see, front shock and rear shock.
Missing the comma of the tape color.
Thank you. And then for the initialize method, we've got style, size, and we don't have style. So we want style, and that is equal to args style, and then let's just do this. We got front shock, rear shock. Right? So this is going to be front shock. This is going to be rear shock.
I gotta learn that. Multiple lines.
That's interesting.
Yeah, very convenient. One of the things that I was told early on, which I still have not done, is to learn your IDE. It's IDE. If you learn everything about your IDE, it will make you more efficient, and it'll reduce your workload that you have to do. So now we want to do, so in the spares, so on VS Code, if you highlight a word, you can select all the words, and then just do Command and D, and it'll select the next front shock. Or if you want to do all of them, just keep hitting front shock. And yeah, so Command D, and then you can make changes how you see fit.
I actually just have Visual Studio Code because of this session, this refactoring session.
Yeah, I don't. It's the only time I use VS Code too, but that happens to be the same command in Sublime also, which is IDE that I tend to use right now. So
Sublime 3 or?
Yeah, Sublime 3.
I remember I used Sublime 2 a few years ago. I actually thought I should also ask Gideon, because I don't know if he has questions.
No, I'm all right.
All right.
Yeah.
Have you joined this before, this refactoring session?
No, this is my first.
All right. Well, last time Nick was saying that the good thing about this book is that you can jump in anywhere and follow along.
Yeah, definitely. All right, so the only difference between the spares is that instead of tape color, it does rear shock, and the tire size is different. It is 2.1, and this is millimeters, 23 millimeters, and this is 2.1 inches. The book explains why that is. Kind of interesting. So in case you're confused by the tire sizes below, know that bicycle tire sizing is by tradition inconsistent. road bikes originated in Europe and use metric sizing. 23 millimeter tires slightly less than an inch wide. And mountain bikes originated in the United States and give tire sizes in inches. So hence the 2.1 inch mountain bike tire is more than twice as wide as a 23 millimeter road bike tire.
That is interesting.
Yeah. I think Sandy is a big bicyclist. She wrote a whole book about bicycles and programming. So the code that we just added, so the code to add these three variables is simple, even mundane. To change the spares proves more interesting. The spares method now contains an if statement that checks the contents of the variable style. And if the style is road, it does. So then, it does two different things depending on what the style is. And if any alarms are going off as you review this code, please be reassured they will soon be silenced. So this example is simply a detour that illustrates an anti-pattern. That is a common pattern that appears to be beneficial but is actually detrimental, and for which there is a well-known alternative. So this code, illustrates an anti-pattern. It looks like, looks like it's fine, but it could be detrimental. And so the bicycle class was doing one thing before, but now it's doing two things. Right now it's responsible for more than one thing. And that's because of the type checking here. So this code makes decisions about spare parts based on the value held in style. So structuring the code this way has many negative consequences. And if you've been following along with the book, this is kind of like a reoccurring theme throughout the book. So if you add a new style, if we add a new bicycle type, a new style, then this method is going to need to change. And then also the last option here is just a default option. So that we can get like unexpected results with the default option. Yeah, it could be unexpected style will do something, but perhaps not what you expect. And then also the spares method, started out containing embedded default strings. And then some of these are now duplicated on each side of the if statement. So you can see, the chain size is now duplicated. So bicycle has an implied public interface that includes spares, size. So we got size, we got spares, and all the individual parts. So the size method still works, and spares generally works. Right? Generally meaning that it generally works. But the parts method are now unreliable. I don't see a parts method, so I'm not.
Yeah.
Oh, maybe like if there was a parts method. I think did we create another bicycle class in the previous chapter? Where's my file structure here? Oh, we did create a bicycle class in the previous. No, that's this chapter. So I'm on chapter 5. We created a trick class, mechanic. Okay, what about this? Gear, wheel. Oh, it's the first time creating a bicycle class that I'm aware of. All right. But yeah, I assume that from that statement, parts method would say all the parts of the bike. So maybe it would grab everything from initialize. It'd be like, okay, so the size is this, tape color is this, front shock, rear shock. And so in order for the parts method to be accurate, we would need to check what style it is and then return what parts the bike has. So not only if we add a new type, a new style type, we would not only have to change the spares method, but we would also have to change the parts method, which, you know, can lead to unexpected, which could lead to bugs, because that just adds more complexity. When you add a feature, you're going to have to change all these methods. So yeah, objects holding on to an instance of bicycle may, for example, be tempted to check style before sending it tape color or rear shock, right? So even though it's a mountain bike, it will respond to tape color, but tape color, you know, is road bike specific. So then if you have an instance of bicycle in some far off class, you might have to check its style before asking the tape color, which is not something we want to be doing. It adds more complexity and we know too much about the class. So these new flaws have broader consequences. So bicycle now has more than one responsibility containing things that might change for different reasons. And, you know, it cannot be reused as is. So this code contains an if statement that checks an attribute that holds the category of self to determine what message to send to self. Right, so right here, this if statement. And then this should bring back memories of the pattern discussed in the previous chapter. So the last 2 weeks, I think, the last 2 episodes, we went through the previous chapter discussing duck typing. And we saw this exact thing where we were checking the types. Right, and we created a duck type to solve this problem.
By checking for behavior instead.
Yeah, so maybe I should bring up last week's file, although we did refactor it, so I guess. Yeah, so last week's file, we had preparers, and for each preparer, we needed to do something different, right? So we were checking if it was a mechanic type, okay, then the mechanic would prepare bicycles. And then we were checking if it's a trip coordinator, then it would buy food and prepare the trip. I'm sorry, it would just buy food. And then if it was a driver, then we would gas up, fill water tank, check seating. But we kind of said, okay, all of these are different types: trip coordinator, mechanic, and what's the other one? A driver. They're all different types, but they're all preparers for trip, right? So we said, okay, well, what we could do is we could just say, ask the preparer just to prepare the trip. So we added a new method, prepare trip, on each one of them, and the prepare trip is responsible for. We just trust that the mechanic knows how to prepare the trip, and we trust that the trip coordinator knows how to prepare the trip, and so forth. We trust the driver knows how to prepare the trip. So we could do something like that here, but it doesn't exactly fit the case for duck typing, because duck typing is for a cross-class. It's for sharing code or delegating code across different classes. Right, so different classes meaning like driver and trip coordinate, or driver and mechanic are completely 2 different classes. They have nothing really in common. But a mountain bike and a road bike, they got a lot of stuff in common. So we could use inheritance to solve this issue here. Whereas So even though like a lot of anti-patterns, a lot of this stuff will look similar, you got to know which design to use. There's many different designs that will solve this problem, but there's only one design that will solve it correctly and cause you less pain in the future. So this is so we saw, so this should be bring back memories of a pattern discussed in the previous chapter on duck typing, where you saw an if statement that checked the class of an object to determine what message to send to that object. In both of these patterns, an object decides what message to send based on the category of receiver. So you can think of a class of the class of an object as merely a specific class of an attribute that holds the category of self. So right now, this class is saying, hey, I know who you are, so I know what you do, right? I know you're a road bike, so you do this here. Else you're not a road bike, and you're going to do that there. And we don't want to so that's basically what that's saying right there. I know who you are, and because of that, I know what you do. This knowledge is a dependency that raises the cost of change. So it just reiterates, be a lookout for this pattern. While sometimes innocent and occasionally defensible, so its presence might be exposing a costly flaw in your design. The Chapter 5, Reducing Cost with Duck Typing, use this pattern to discover a missing duck type. Here, the pattern indicates a missing subtype, better known as a subclass. So finding the embedded types. So type and category are words perilously similar to those you would use when describing a class. After all, what is a class if not a category or type? So basically it's saying, if you ever see like you're using these words, you're checking like the type of a class or category of a class, then it should be a red flag. So this problem here is the exact problem that inheritance solves, that of highly related. So that's the keyword, that of highly related types that share common behavior but differ along some dimension. So back in Chapter 5, these classes don't fit that definition. They're not related types, and they don't share common behavior. They're pretty unique and different, so they don't fit that definition of when to use inheritance. But mountain bike and road bike definitely do. They are highly related, and they do share common behavior, but they do differ along some small dimension. So so choosing inheritance. Yeah, I'm not going to read all this. It kind of explains what inheritance is again, and then it also talks about multiple inheritance. Like so Ruby only supports single inheritance, but some languages do support multiple inheritance. For example, you have two parents. Languages that allow objects to have multiple parents are described as having multiple inheritance. And the designers of those languages face interesting challenges. For example, when a subclass, so when an object with multiple parents receives a message that it does not understand to which parent ought it forward that message to, and if more than one of its parents implements the message, which implementation has priority. So it can get, kind of complicated. I don't remember. I think, does Java support multiple inheritance?
I was thinking the same thing. I was thinking the first thing I thought of was Java.
Yeah. I know it supports multiple interfaces. I don't know if it supports like multiple class inheritance. Multiple inheritance, Java and multiple inheritance is a feature where class can inherit properties of more than one parent class.
The second link implies it.
Yeah, it looks like it does support multiple inheritance. So
But Ruby keeps it simple and avoids some of the headaches of
yeah.
having singular methods.
Okay, so question. Uh, when you say Ruby supports only that's a single inheritance. So that means when I have my class A, then I define another class B which inherits from A. I cannot define another class named C which inherits from B.
Um,
So that's the
Well,
point
the
of.
way I understand,
Mhm.
it's like it's a bit difficult to hear you. So you're saying that B inherits from class A
Yes,
and
so
C
I.
inherits from
Mhm.
class B,
Yes.
and that's possible because
yeah.
class C would have one superclass, which is class B, and class B would have one superclass, which is class A.
Okay.
Yeah, this is perfectly fine. Like this type of class
Mhm.
structure is, yeah, and then class C doesn't inherit from anyone. That's perfectly fine because it only inherits from one class. So you can
Mhm.
kind of follow the chain upward. Let me put
Okay.
this down here. So here, class A only inherits from class B. And so if a method, let's say nil, for example,
Mhm.
if you call nil on class A and it's not defined in this class, then it says, okay, check the parent class. The parent class is
Mhm.
going to check the parent class. It's not going to find nil. So then it
Mhm.
says, okay, check its parent class, and it's C. And then you can see, okay, well, class C defines the method nil, so we can so then it finds the method that way. So it just goes up the chain. It only inherits from one, even though it has got multiple ancestors.
Yeah.
It only inherits from one of those ancestors at a time, right? So class A inherits from B, B inherits from C, and C is the top
Yeah,
dog.
each class only has one parent. Multiple inheritance, one class could have more.
Yeah. So in Java, you could say, okay, class A inherits from B and C.
Oh, that makes sense now. Because I was
So
wondering, multiple inheritance, how? Yeah, I think that clarifies now.
okay, cool.
Yeah, thanks.
Right on. You're welcome. Um, yeah.
In the meantime, I can't continue in Visual Studio Code.
Yeah, I saw a message. It looked like you
And
got.
but the reason is I have something on my computer that is using up all my memory. So I don't know
Oh,
if I've got my antivirus is running, but I don't know. Maybe.
oh, antiviruses tend to take up a lot of.
No, I mean I don't mean that that's the cause. I mean it's running because I'm looking for something.
Oh, okay. Yeah, I mean
Because this
they
is
they
just
do they do tend to take up a lot of memory though.
this is just today. Since I switched on my computer today, something it keeps using up all my memory. And if I look in the task manager, it won't show up.
Oh, okay.
So I think maybe I got a dubious file yesterday.
Oops.
Hello.
Streaming. Yes.
Hey, Mike.
Hello.
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 We can hear you. Can you hear us? Oh no. Well, put your put your headphones on. No. All right. Yeah, sounds good. All right. So yeah. So I'll wait. Maybe Mike will just be a minute. Let's see. I'll check back in a minute. So yeah. So implementers. So designers of that language that support multiple inheritance, they face their own design challenges that they have to solve. Ruby keeps it simple. Only one class can inherit. It only does single inheritance. So message forwarding via classical inheritance takes place between classes. And because duck types cut across classes, they do not use classical inheritance to share common behavior. So duck types, they share code via Ruby modules, which we get into in the next chapter. So even if you've never explicitly created a class hierarchy of your own, you do use inheritance every day. So when you define a new class but do not specify its superclass, Ruby automatically sets your new class's superclass to object. So so like here, if I create a new class, I think Georgie and I were doing this at the beginning. So if I create a new class, any class, and don't define any behavior in that class, I can, and then I instantiate the class. And then I ask any class what its methods are. It comes automatically with all these methods because it inherits code from object. So if we ask any class if it's nil, it says false because it inherits these methods from its parent class, even though I did not specify a parent class. And what its parent class is, I think it's super class. Is that how we do it? Any class dot super class should be here, right? Oh no, I don't see it. Methods class parent, is it parent? Any class dot class, it says it's in any class. Oh well, there's a way to ask it what its parent class is. I forget how to do that. Does anybody know?
Nope.
What did you try? I wasn't watching, sorry. Did you try dot super or something like that?
I did. Let's see. Let's ask Google. Ruby get class of parent. I thought I did try parent. Oh, superclass. Okay. It's not listed as one of the classes there. Let's try it.
You have to call it, I think, on the class itself.
Oh, okay. So any class dot class. Let's do that. Any class dot class dot methods.
Yes.
Not parent. Yep, superclass. Yep, there it is. So any class dot class dot superclass. Why is it? Oh, it just does b dot superclass. Okay, I see. All right. Let's do this. So any class dot class, it says it's in any class. So then if we do any class dot superclass, it inherits from object. And then if we ask what object inherits from,
That's the class.
it's basic object. We ask what basic object inherits from, nil. It doesn't. Basic object is at the top of the food chain. So if a method is not found in any class, it checks its superclass, which is object. If it's not found there, it checks basic object. And if it's not found there, then it blows up. It throws an error. it throws the method missing. Yeah, the method missing error. I think we've gone about 50 minutes now, so we should probably try to wrap this up. I think we got about halfway through the book.
You mean the chapter?
Yeah. Thank you. Halfway through the chapter. So, and we are left with this. We got it all coded up. So next week we will refactor this and start doing the inheritance. So this is the UML of what we just did through, right? Object actually defines nil, and it always returns false. And then nil class, which is a subclass of object, it actually defines the method nil, and it always returns true. And it says that these are the only two places where you will find the method nil defined. Everything else does not need to define nil because it inherits from object. And if anything else is an object, then it is true, except for the nil class, nil object. And it explains that in more detail here. So the current bicycle example embeds multiple types inside the class. So it's time to abandon this code and revert to the original version of bicycle. Perhaps mountain bikes are a specialization of bicycle. Perhaps this design problem can be solved using inheritance. And it says perhaps, and it'll discuss why it says perhaps instead of it can definitely be solved using inheritance. So we'll get into that too. Drawing an inheritance relationship, so it's gonna use the UML diagrams here. The hollow triangle means that the relationship is inheritance. So if we look at it, we can see that mountain bike inherits from bicycle. So the first refactoring is that it does it incorrectly, misapplying inheritance. We can see here that, so this is what we'll do. We'll create a new class mountain bike that inherits from bicycle. And we say, okay, mountain bike, it can have front shock, rear shock. We initialize front shock, rear shock, call super. And then to get the spares, we'll call super and then merge rear shock. I guess we don't use front shock in the spares. But yeah, so this will be the first thing that we do next week. Yeah. Yeah. Yeah, so we'll start. We'll continue following along with the book. And at first,
Mike,
yeah.
You still there, Mike?
I don't think he was able to rejoin.
Okay. No, I just wanted to mention about the times.
Yeah. So I'm going to send out a group chat to everyone
in
Slack, and we'll figure it out over the next couple days, hopefully, and
right.
We'll get it straightened out. Do you have a preferred time, Gideon?
No, but I'll be available. I'm always available.
Okay.
Yeah.
All right, cool.
Because we'll probably be an hour earlier than today.
Yeah, sounds like it.
All right.
Cool.
Thanks, Nick.
Thanks, Georgie. Thanks, Gideon. And we'll continue next week going down the inheritance path.
Okay, awesome.
Awesome. Thank you.
Ciao.
Ciao.